There's a few more people still checking in outside, but we'll go ahead and get started if those of you could take your seats. And speakers, we've got your seating area over here on this side, or you could just come up whenever your segment starts. Good morning, I'm Tim Zork, your county commissioner here for District 3, as well as your moderator for today's program. I'd like to welcome you to my 5th program on the Indian River Lagoon. Some of the past segments have been, are we making progress in helping identify the issues facing the lagoon? We have a nice crowd here today, as well as this is being filmed live on the local government channel, and you can replay this at your leisure through ircgov.com, as well as it'll be on the local government channel as well. We're fortunate to have a distinguished panel with us here today. I don't know where they're all sitting at the moment, but we'll start off with an introduction with Dr. Dwayne DeFries from the Indian River Lagoon Council. We also have Dr. Dennis Hanasak from FAU Harbor Branch, who's in the back of the room there, and Dr. Gary Zarilla, who will be kind of the closer of the speakers today. He's from FIT, who's actually doing the flushing study research in the Bethel Creek area, as well as the northern end of the Indian River Lagoon near the Banana River. Some of our speakers today have other speaking engagements at lunch, so we'll have a short, probably 10-minute question and answer session between each speaker so they can make it on to their next obligation. And then we'll obviously have a little bit longer Q&A at the end of the program. Before I'd start, I'd like to give a few thank yous to those who helped provided the funding that provided the opportunity for FIT to undertake the flushing study research. And they are special thanks to Senator Debbie Mayfield's office. And I think we either have Adriana or Caitlin with us today. I'm not sure. We also, special thanks to Representative Randy Fine from Brevard, and also longtime friend, former county commissioner in Brevard, former state senator for our area, Representative Thad Altman, who was the one that made sure when the funding was put in the budget, it was Brevard/Indian River, so that we had an opportunity to be included in the flushing study. I also like to just call out some of the county staff we have with us here today. Jason Brown, our county administrator, over on my left. Rich Spurka, who's going to keep the room nice and cool for us this morning. This room is not normally cold on Wednesday mornings. We also have Brenna and Scott helping with some of our IT, and also like to recognize David Jackson from Congressman Posey's office, who's here with us today. And with that, we'll start off with Dr. DeFries from the Indian River Lagoon Council. And when we do the questions, Dwayne, if you could, at the end, is repeat the question so it's picked up on the mic so those at home can follow along. Thank you and welcome.
Thank you, Commissioner. Good morning, everybody. If you came in, hopefully everybody grabbed one of these. This is our National Estuary Program annual report. We often get the question, who's doing what and where's your money going? This is our way of showing you exactly where the National Estuary Program dollars are going by projects. And this year, for the first time, we've highlighted projects, throughout the counties that our partners are doing. And there's a lot going on. So the first question I get is, what's the water quality looking like this morning? And I want to give you, thankfully, it doesn't look like this. And this is kind of the images we've got over the last 8 or 9 years between cyanobacterial blooms to the south, brown tide blooms in Banana River and Indian River Lagoon, and some strange other critters up by Cocoa with that really red water. But right now, we are looking quite good. In fact, we have gone through our winter season. It has been dry, and so that is working in our favor. Water clarity in many places is as good as we've seen in 4 or 5 years, and so that's the good news. I'm getting reports almost weekly from boaters who are saying, gosh, Dwayne, I'm looking at massive expansions of seagrass, and I want to just show you. I don't know how well you can see it. Here's a seagrass. What many people are seeing is this algae. It's called Caulerpa. It's kind of an intermediate, species. It's not a seagrass. It's good news to see it. It's taking up nutrients, but we are still only modestly seeing seagrasses on the comeback. But right now, we're getting reports of seagrasses in places we hadn't seen in a few years. And so that's the good news. Weather's been good to us. Here's the worry, at least my personal worry as a scientist, and I've been here for 40 years. This has been a warm winter. Water temperatures are warmer than I'd like to see this time of year. And so stay tuned. I mean, next week we could have an algal bloom. There's no way to predict, when this will turn. But as we get into the warmer, rainier seasons, we are not out of the woods yet. The Indian River Lagoon is vulnerable. It's always right on the edge. And so it's a big system. Usually it doesn't all turn at once, but expect to see some bad water quality as we move into the summer and into those warmer summer areas. So really quickly, and I didn't know where the background of everybody would be, we've got a complicated system. It's 156 miles long. It's got multiple jurisdictions, 7 counties in the watershed, over 1.6 million residents, 38 incorporated cities. And so when we look at this watershed boundary, and you can see how it expands all the way to Lake Okeechobee in the southern end, you can't manage this system as a single system. You have to manage it in units. So when people ask me, how does the water look, I usually say where. And then they say Indian River Lagoon, and I'll say where in the lagoon. And they'll, it really does vary that much. And it can vary within a mile or two where you have real good clarity, for example, just out here and go 2 or 3 miles and be in a small bloom. We also have a lot of impacts, and I'm not going to spend any time on this other than when you start to think about all of the impacts, habitat, stormwater, changes in landform and land use. When you drive down to how do you respond to restore a system and be a steward of the system, the bottom line, it always comes down to water quality and clarity. And this is what we've looked like over the last 9 years. Since 2011 in the super bloom, we've had recurring brown tides in Banana River that only really stopped for any length of time this past year. We've had moments in 2014-15 where we've had a bit of a break. The timing of this is really important. So seagrasses want to come back right about now. Right about now, we'll start seeing the growth season. And if we get algal blooms early, then those seagrasses never get a chance to retake. And of course, those of you who are aware of the massive fish kill in 2016, that is always the risk of an event. So we like to look at the system from 2 different kinds of impacts: the long-term stressors and then the shocks, like a hurricane, like a fish kill. We're down in the southern end of the lagoon, when we're pushing billions of gallons of fresh water from Lake Okeechobee through the St. Lucie River and estuary. That is a shock event. Even if that water was 100% perfectly clear and clean, just the salinity shock would change the nature of that southern estuary. And so we need to be managing those differently as we move forward. And this is, of course, pictures of that 2016 event and 18 again, where we had toxic cyano blooms. So the question is, what do you do? And so when it gets down to beyond the science and you start looking at historical restoration that's worked, places like Chesapeake Bay, Puget Sound, Tampa Bay, it all comes down to looking at where the sources of nutrients and pollutants are and stopping them at the source. And also looking at those internal sources, and you can break those into, a lot of different categories, but I like to break it into the simple stuff. It's all about wastewater. It's all about septic systems. It's all about stormwater, and stormwater varies in scale. You got urban stormwater coming off your street. We also have large stormwater conveyances like the main canal here in Indian River County and our big tributaries like Sebastian River, Crane Creek. And then also the muck that's in the system that's accumulated over the last 60, 70 years. That becomes not only a problem as it relates to nutrients, but it also is a problem as it relates to sediment and water clarity. So the key is, start to address those root causes of the problems. And I wanted to just bring this up because it'll be pertinent to the discussion you'll hear later. I've had a chance, some of you are from Bethel Creek. I appreciate the invites to go see the system. I've paddled it, I know it well. And you're going to hear about flushing, and very often, there's a lot of misinformation or confusion about, what does dredging really do? This is data that just came out of Brevard County. It's preliminary data. Brevard has had pretty aggressive dredging, maintenance dredging for muck projects for the last almost a decade and beyond. But the question always becomes, well, isn't dredging damaging? And how do we know dredging is making a difference? So this is very preliminary data from Brevard County using the data set from St. Johns River. And if you look at Turkey Creek turbidity, the average, these NTUs, are just a way scientists. It's a metric of turbidity or cloudiness using light penetration. You can see the average, is 3.79. As we move into the muck dredging process, it was a slight increase, but really no great change. So no major damage during the dredge. And then post-dredging, a significant improvement in water clarity. Now, I hear this from citizens post-dredging because I get phone calls and they'll say, hey, my dock, I haven't seen it this clear in a long time. So this is one example where we can at least say the preliminary data is suggesting dredging is actually making a difference in water clarity. Here's another one from the Ogallie River dredging, which was particularly challenging because of how far they had to pump that dredge spoil. So this is the average going back from 09, 6.7, no change, and then a reduction. And so that no change, just a little bit of an increase, but not statistically different, and then a statistical change. So dredging is a tool. Only about 10% of the lagoon has muck, but it is a tool that's useful. We know it's successful. It's not, there are no silver bullets, but I wanted to at least show you some of this new data on dredge. And this is an interesting one. We're seeing this year, and this is not unusual, this year we are as clear as we've seen in literally 9-10 years, and that a lot of that is weather driven, but it does show you that nature can really impact some of the things we see in the lagoon, and the lagoon is highly variable based on the weather, the rain, the wind. So we basically have a plumbing problem that we need to address, and that plumbing problem needs to focus primarily on reducing nutrients, pollutants, and sediments to the system. And we're growing, and so we have this problem today with 1.6 million residents. If you look at this data, and you look at Indian River County and St. Lucie County, some of the per cap growth over the next 10 years is going to be here as this county and the counties to the south begin to expand westward, with a lot of ag lands going to rural residential and more urban settings. And so some of the challenges we see in Brevard County relates to land use patterns and population growth. And thankfully right here, you're lagging behind, so you can use some of this new science as you move forward in Indian River County to think about zoning, to think about, how do you build, how do you do better stormwater, how do you do better, water treatment, should we be doing septic, or maybe advanced septic is the best way to move forward. So where does the Indian River Lagoon National Estuary Program come in? We are a federal program. We are in the Clean Water Act. We are now 30 years old. We've been operating for 30 years on the Indian River Lagoon, and we're unique in that we work through a non-regulatory process. And so a national estuary program works with stakeholders to find common ground to move forward to not just restore a system, but also to be stewards of that system. And under our authorization within the Clean Water Act, we are obligated to be able to set up a system. It's called a management conference that ultimately will create a comprehensive conservation and management plan. And I'll talk to that in a minute. But I want to show you where those dollars go. So this is a graph of the first 25 years before we created the IRL Council in 2015 to better address the problems of the lagoon. And so over 1,100 projects, 27 million distributed to the 5 counties for projects. And I will admit, those projects were focused differently than we focus today, because the system looked like it was responding favorably. We have, in that time, changed our vision, our mission, and our goals to address the challenges of this moment with the idea that the goal is clean water and a healthy ecosystem with healthy sediments. We've expanded our cost share. So back in the day, for 25 years, we operated really just on the federal dollars. About $600,000 a year comes in through EPA. And in 2015, when we reorganized contributions, and thank you, Indian River County, each of the counties bring $50,000 in, both water management districts $500,000. We have that $600,000 from the feds, $250,000 from DEP, and so we have increased our capacity to do work, even though it's still a modest amount of money. And so since 2015, over 100 projects moved forward, 8.2 million. And just in the last few weeks, we've got 12 new projects coming online in the fall. And they look at a range of issues, but with a focus on water quality issues and habitat restoration and applied science. Where we have questions, we need to answer. So it's just a quick example to show you. I respond to 100 volunteers, a whole scientific committee, a citizen advisory committee, a management board, and then a policy board that is our board of directors representing the investors in the program. So this is really a citizen-driven program. And one of the most important things we do is every 10 years, we develop, with partnership, a new comprehensive conservation and management plan. The new plan has now been adopted in August. It's been vetted by the EPA. It is the big highway moving forward over the next 10 years. I want to spend a moment on this. So we have identified 32 lanes of the highway. Everything in the blue in that north part of that circle relate to either water quality or habitat or living resources issues. In the lower right-hand corner, in the kind of brownish colors, are those colors that relate to you and your community. You know, things like litter, things like unique community resources, even climate change falls kind of in that group. And then in the lower left-hand corner, you will see the things that we as a national estuary program deliver for you as our communities. Everything from the comprehensive management plan, coordinating the financing and the partnerships, but also the strategic planning. And so, most important, we do not tell Indian River County or, you know, the city of Sebastian or the city of Vero Beach kind of what to do. We really do respect local home rule, but we will give you that broad 32-lane highway, and what we're telling everybody is if you own a problem in this wheel, in one of these vital signs, fix your problem. If you're a citizen, you know, with a septic tank that hasn't been inspected in 25 years, get it inspected. If you're a municipality, you know, with stormwater issues, work on that. That if we all, at every level, you know, work on those problems within a decade, you know, we will start seeing an improving lagoon, and then beyond, we should get us back. And we've seen this happen time and time again. You know, if you stay the course and do those reductions, you will see improved water quality. And it's all about partnerships. And one of the most important partners is the private sector. And so we also work with private sector partners, you know, where we can and when we can to make sure that industry is at the table with us. We can't do this just environmental groups or just citizens. This is a whole community effort. And we have to work together as a community to get there. And we've identified 10 actions. I won't go into the detail. You can go on our website and see some instruction on where we see. But it's all about these 10 R's. What do you remove? What do you rebuild? What do you reduce? How do you, restore? And they all relate to two things. Us taking responsibility for the health of the Indian River Lagoon and then having resolve to stay the course. We are in this forever. It's not a one and done where you fix the problems in a year or 10 years and then you walk away. We don't do that with tourism. We don't do it with economic development. You can't do it with clean water. So I'll leave you with this, and you can find this call to action video, either on YouTube or on our website, onelagoon.org. It's a nice 6-minute encapsulation of things that we need to do as citizens and think about as we move forward. And I want to leave you with this a little bit arresting reality check. So when we do our CCNPs, we actually looked at projects. We assembled more than 480 projects from our cities, from our partners, from our state agencies, and we're looking at probably somewhere between $4 and $5 billion to do all of the work of a national estuary program to restore the system. Doesn't mean you need to do every single one of these to see improvements. In fact, you don't. But if you think about $4 or $5 billion, the first thing I get when I go to Tallahassee is this. What? Where do you get that kind of money? And I want to put this into context for you because the value is there and you don't have to eat this elephant all at once. You can do it over a 20-year period. But Brevard County, their half-cent sales tax is generating $48 million a year over 10 years. So it'll be $500 million from their half-cent sales tax. Congratulations to you here in Indian River County. You've been applying part of your discretionary sales tax to the lagoon-type projects for a number of years, and you've done some really innovative projects with local cost-share dollars. Osprey Acres is the one that comes to mind immediately, a really large regional stormwater park just completed by the county and partners. But when you think about value, this is where it really hits home. So the estimated economic value of the Indian River Lagoon, 2 independent studies, Brevard County and this Treasure Coast Regional Planning Council, between $6 billion and $7.6 billion a year of annual contributed value to our communities. Every dollar used for restoration brings in values between 33 to 1 and 20, so between 20 and 33 to 1. So you're getting value when you put $1 in for restoration. And so when we start thinking about investing in clean water, investing in the lagoon is a good business decision. And bad water is a detractor to all business, whether you are in small business, tourism, property value. When we have fish kills and we have dirty water, we have economic problems. This report was just released last week. It is a roll-up of the entire ocean and coastal economy of the state of Florida. And that last bullet, the economic contribution just from direct and indirect use of ocean resources, almost $74 billion, 1 million jobs within multiple sectors, and then the coastal counties in Florida, over $797 billion. And so this is not a small portion of our economy. It is the foundation of Florida's economy. And it's all based on clean water and managing our resources. But, we don't care about the dollars as much as we care about quality of life. And so as you hear water quality in the next speakers, you hear some intervention strategies that Florida Tech's looking at. This is all about maintaining the quality of our lives here in Indian River County and throughout the lagoon. And it's about making change, not just wanting change, but making change. And that's hard because we have to do things differently than we did the last 50 years. Some of that's simply with how we manage our lawns, with less fertilizer or maybe no fertilizer, less pesticides, less herbicides, maybe no chemicals. But those individual decisions are meaningful and valuable. And so as you take action, think about those individual things that you do just on your properties, and also think about some of the bigger things like supporting clean water funding. Without a recurring funding stream, this work is really hard. I leave in a few weeks, go to Washington, D.C. We fight every year for a funding. We've been up in Tallahassee the last couple of weeks. We're at the tail end of the session. I think we're going to see some good funding for water, if not excellent, historic funding in the big picture of water, and good funding for the Indian River Lagoon. But these are the two bills at the federal level that are encouraging to me. Both the House and the Senate have submitted bills in Congress to double the base funding for the National Estuary Program. There are 28 of us nationwide dedicated as estuaries of national significance. 4 are in Florida: Indian River Lagoon, Tampa Bay, Sarasota Bay, and the Coastal and Heartland National Estuary Partnership down in the southwest corner. This is a sign that we are starting to get our word heard, that it's going to take more funding to maintain clean water, and that's going to be at local, at state, and at federal levels. So with that, I'll leave you with this last thought. It's about time for not incremental change, but transformational change. And we do that first individually, and then in chambers like this. Indian River County, the commission has thought outside of the box for many years. I remember the National Estuary Program funding the periphyton flowway, I don't know how many years ago. That was cutting edge nutrient remediation technology at the time. And so we need to think transformationally, invest transformationally, and act. And that doesn't happen without your support. So with that, I'll just close and take some questions, and thank you all for your support for clean water. Yes, sir. Excellent question. I'll repeat that. So the question was, we hear a lot about septic systems as being one of the drivers and a primary concern. Do I believe that? And what is the context of that? The answer is yes. Traditional septic systems contribute nutrients to land and groundwater. Back in the day when we were a rural community, septic systems, individually didn't contribute individually much. But think about where we live. We have high water tables close to the lagoon. We have septic systems, many of which may be 40, 50, 60 years old, all contributing nutrients to land and groundwater. I'm going to say this. I believe that traditional septic should be illegal in the state of Florida, based on what I've seen. There are options, though. Advanced septic, can do a massive job on reducing nutrients to the system. And of course, wastewater, centralized wastewater is the way we need to go. I mean, who would have thought we'd be approaching, 21 million people? The problem with septic is that septic is not a 21st century wastewater treatment for urbanizing communities. And so we have 300,000 septic tanks along the Indian River Lagoon watershed. We really don't know how many of them are functioning because we don't inspect them as a mandatory, regulation in the state. But we do know one thing. All traditional septics bring nitrogen and in some cases other pollutants. If you're dropping your pharmaceuticals down your toilet and you have septic, that's straight going through your drain field. And so we need to address wastewater treatment. Septic's just part of it. If we have 300,000 septic tanks and our centralized wastewater treatment is not up to snuff or doesn't have the capacity, then you've got this, catch-22 of where do you go? We need to be updating wastewater treatment to 21st century standards, which is a minimum of advanced wastewater treatment and we have many systems that aren't there. So wastewater is a central issue, sir, and one that, you know, we need to be looking at as we grow. And to be honest, it's good for value. Communities in the 21st century that have good wastewater and really good potable water can grow. Those that don't will have problems in economic growth and expansion because it will be a deterrent to both property values and future growth. Questions? How am I doing on time? You guys are like the easiest audience I've had in 2 weeks. It must be early morning. Ask me a hard question. Yes, one more. Yeah, you can do that later, but I've looked at, you know, I've got a stack of, you know, almost 3 inches. You could go back 100 years. We've talked about, you know, new inlets, pump stations just recently, culverts. You know, the key is you need to know what outcome you want. And then if you know what outcome you want and the parameters that you need to be testing to make sure your outcome is met, you know, then you can start to engineer to that outcome. We have seen over history some engineering solutions that turned out to be pretty major problems. And the biggest is Lake Okeechobee and the dike and this pumping of, at times, as much as 9 billion gallons of water. You know, back when that was done, it seemed like kind of a logical, you know, way to get land to agriculture. And now we know the terrible, you know, cost of that decision. So the key is understanding what outcomes you want and looking at the whole suite of tools, both biological, you know, sometimes chemical, but clearly natural and engineering, and then put the right solution to the outcome you want. Make sure you understand the problem set. So, and I'm sure Gary Zarillo will talk to that a little bit later. Well, thank you very much. I hope you all have a great morning.
Thank you, Dwayne. And not just for today, but for your many years of service, both in the private sector and public sector, that I think made you poised to be the right person to manage the Indian River Lagoon Council. Our next speaker is going to be Dennis Hanasek from Harbor Branch FAU, and he's going to speak on some interesting aspects of how do we keep track of progress in the lagoon, and their device they use is the Lobo. And I'd like to welcome Dr. Dennis Hanasek.
Dwayne, I'll take your extra minutes that you left over. I didn't expect that.
Yeah, once in a while I get lucky.
So I want to thank the commissioner for the invitation. It was very nice. And we can go right to the slides. So I'm going to show you a quick outline first, so you know kind of what I'm going to take you through. I'm going to try to cover quite a lot. I'm going to tell you about our network of environmental sensors. I'm going to try then to show you some data. I'm going to focus on primarily Indian River County, obviously, because that's what we're here today. And I'm going to do this at different time intervals. So we've had some water quality now from this part of the lagoon for 5 years. I'm also going to then kind of take a look at the last year. We know what is most current, because that's usually what people want to know about. So one of the themes is, and it's already been kind of mentioned by Dwayne, is that the lagoon is so variable from year to year, and that's one of the biggest challenges we face, to try to understand it or to try to manage it. Some big things happened in those 5 years. We had some hurricanes. Of course, they were really just tropical storms for us, fortunately. We've also had some periods of droughts, and then I'll have some, if time permits, I'll tell you where we're going next. So you all know about the lagoon. You all know it's a special place. Just looking around the room, I recognize a lot of faces, so I don't think I have to explain very much about that, especially following Dwayne's nice comments overall. So about 8 years ago, I started something called the Indian River Lagoon Observatory, IRLO for short. And the whole idea was, this was at the time when, you know, we saw things were changing. I had already started to do this, and then we had all these harmful algal blooms, loss of seagrass, fish kills, and so on. And it just seemed obvious to me that we need, as scientists, to do a better job in terms of gathering our data, using existing data, kind of making it more readily available. So that's the type of observatory that we are. And there's several key aspects of this. One is we're looking at long-term ecosystem type research, collaboration, and Dwayne also talked about partnership. Really, really very important among organizations. So one of the things we did, we started the Indian River Lagoon Symposium. Again, looking around the room, a lot of you already know about that, but it's a once-a-year meeting when we get about over 300 scientists and managers who come and talk about the lagoon, what the current work is, and we share those results. And what I'm going to talk about today is the last bullet, which is the network of advanced observing stations. So we called this our Indian River Lagoon Observatory Network of Environmental Sensors, IRLON for short. And basically, it's a way to provide real-time, high-accurate, high-resolution, I'm going to use a longer word, biogeochemical data and weather data. Biochemical, we can translate that probably in most cases to water quality. That's what most of us are used to talking about. And a key thing is that you can get this data as fast as I get it. So it's readily available. It's publicly available to anybody who wants to use it, really for whatever reason. This is a list of all the parameters we measure, and I'm not going to go through them all. I'm going to show my examples. I'll briefly explain, what the importance of each of those would be. I'm not going to cover them all. Also, at most of our sites, but not all of our sites, actually only one of the 4 sites in Indian River County has a weather station. But we will be adding weather stations to all of them in the near future. And we think coupling the meteorological data with the water quality data is really important, especially for some of the events like hurricanes that I'll be talking about. A lot of people really aren't sure, what are we talking about when we put these sensors? What do they look like? Well, this is what it looks like inside the system. We have basically a data logger. Up there it's called the Storex. We have different sensors. Most of them are optical sensors that basically use beams of light to figure out what's in the water. And that could be chlorophyll A, like the pigment in the algal blooms. It could be the turbidity. Turbidity has already been mentioned to you earlier, and what that is. And we have a chemical analysis, the Cycle P, the big canister on the top, which actually has a little automated chemical reaction that goes on every hour that measures the phosphate in the water. And we have more sensors. So the first time it goes out, everything looks nice and clean. It never looks like this again. If anybody has a boat, you put a boat in the water, you put anything in the water, you know what incredible fouling is. And I do believe that of all the places that have these systems, we probably have the biggest challenge of anybody when it comes to fouling, because everything grows really well in the lagoon. So we protect it a lot. We use a lot of copper tape, for example, to discourage growth. All our sites, except the one near Harbor Branch, where we actually have our own little spot, we partner with the Coast Guard, and that works out really well for us. Once they give me permission to use their navigational post, to touch anything out there, you can't touch that. That's the federal government. It's something that gets you in a lot of trouble. So I have really good security. I really like that, and they've been really very generous with us. But that's typically what a site looks like. If we look above, when we have a weather station, you can see the weather station elements are on the top. So we measure things like humidity and rainfall and light and wind. You can see a solar panel, so everything is powered that way. And it feeds into a battery. And a lot of people say, well, you keep these out in the hurricanes, that panel's going to go away. I understand that. That's okay. I want the data before it blows away. And we'll continue to get data until the battery runs out. And at the way we set it now, we would have at least another 48 hours, and we could change that to make it last longer if we wanted to. You can also see there's a little antenna. Basically, it sends a cell phone call to a computer server, and then the data goes out, as I said, real time, or nearly real time to everybody. I have some cards that I'll leave up here. I have more if they run out. If you want to remember how to access the data, you can also just basically Google, Harbor Branch water quality or IRLO water quality or LoboViz, any of those things, we'll get you to a landing page. If there's time later, maybe after the formal session, I'm prepared to walk anybody through the website, if you want to see what it looks like, for real, and also more importantly, how to pull the data down and look at the data, on your phone or on your computers. There's a lot of reasons why we think this is a good thing to do. I've listed them all up there, but in short, there's a lot of different types of users. Some of them are like myself, or possibly Dr. Cirillo. He might be able to use the data as a scientist, in the lagoon. We have managers, such as the folks that are from the agencies or the counties that are in the room, that can use it in terms of management decisions. This can be really important for modeling efforts, because to really understand the lagoon, we need a lot more modeling, we need a lot more data, we need a lot more verification of those models. But also, it's just a great platform for education and outreach. So we find that students can really understand the lagoon by looking at the data, playing with the data, if you will, and as can the average person, such as yourselves. I personally am interested in some of the big questions, like how does the interaction of freshwater and saltwater in this estuary impact various parameters. Many of you probably know I work with seagrasses and plants, so I'm very interested in what reduces light availability to seagrasses. And there's 3 sensors on that IRLON site that tell me a lot about what happens with attenuation or reduction of light. What's the relationship to algal blooms, and so on. So here's a map of all of our sites. We currently have 10 sites, and we started actually right at Harbor Branch. LP is for Linkport. Some of you may know that is an old name for our location, but it's one that I like to keep using. And then we got some additional funding to go to the south to Fort Pierce, just north of the Fort Pierce Harbor. And then we put a site Vero Beach, which is not too far from Oslo Road, and then also up near Sebastian, just south of the inlet. So that's where our sites are that are most local to you. And we started that initially, the first site was in 2013, and those sites came on in 2014. And then we had a big opportunity in 2015 to develop what I call our southern network, which is all focused on the St. Lucie estuary. And I will only briefly mention St. Lucie estuary data and Lake Okeechobee, because I get a lot of questions always about it, and I think I need to do that. So we're not sure how much this is going to shake. It doesn't normally shake like that, but those tiny tremors are not quite normal, but I think I'm going to show it anyway. We saw this when I first tested it up front. But this is basically what one of our sites looks like. I want to show you that it takes a lot to get the data. A lot of people have the misinterpretation that it's like plug and play, you just throw it out. So that's what one of our IRLON devices look like when they get pulled up. You can see there's a lot more fouling. We document everything. We document all the information we're getting from sensors, but also we take pictures of the fouling. We're now working on that phosphate canister. There's three containers that are around that unit have reagents and actually a standard known phosphate solution. And those have to be replenished periodically. About every 6 weeks is how long they're good for when we do algae measurements. So you can see one of our folks is taking apart. That's actually the SUNA. He's cleaning that optical area there. The SUNA is what measures nitrate. So, when I first started getting into this, one of the reasons I got into it is because I didn't really think it would work. I thought it would be impossible to really get long-term nutrient numbers. And it's quite a challenge, but it turns out you can do it. And so we're basically checking out various parameters for each of the sensors, making sure everything works. If not, we're taking corrective action. And then we basically, at the end of it, we'll put back everything and continue on. So I think we can go ahead and don't need to show the rest of that. I think we can just move forward. So I guess I can do that. Okay. So I did that to give you a break before I show you a lot of data. My intention here is not to overwhelm you with data. My intention is to say that I just did this about 2 days ago. I went online and I just said, well, what am I going to say, to all the folks in your county that might be coming? And I just thought, well, this is what has been interesting. Temperature, I think we all know. We know a lot about that. This is going to be IRL Beach. So this is our site down near Oslo Road, and it's a 1-year cycle. So I'm here to tell you shocking news. It's warmer in the summer than it is in the winter. But everybody always wants to know how hot, how cold, right? And we've had some very extreme cold weathers, such as in 2010, 2011. You might remember all the turtles that were stunned, all the mortalities of fishes, and so on. And that's information that is actually really important to have. And it actually gets fairly warm in our local waters. It's about 32 degrees centigrade, which is just about 90 degrees, which is pretty warm for estuarine water. And it gets fairly cold, 15 degrees. It can get lower some years. That's about 59, okay, Fahrenheit. Okay, that's a pretty easy one. So I work you into this slow. Now I'm going to show you like 5 years of data. Again, just at our northern network. So this would be the 2 spots in Indian River County, the 2 spots in St. Lucie County. And all the data is thrown there together. But my point is basically to show that long term, there's these huge swings in salinity. And everybody in the room will know what causes low saltiness, right? It's really rain, and more importantly, how much water gets flushed out of the canals. Locally, most of that comes right here in Vero, the 3 main relief canals. That's where the bulk of the water comes from. Oh, but to the north, we also have the St. Sebastian River that impacts the lagoon that's in the northern part of this county. But you can also see that year to year, it's enormously variable. And we all remember some very wet years and remember some very dry years. We can simplify this by just looking at, again, just that one station in Vero for the last year. And many of you may recall, for example, we had a huge rainfall event, near the end of the wet season, like in September. And you can see the salinity's really plummeted quite a lot and stayed low for some time. But typically, this is what we see. This is the dry season. This is the winter time. This is when we have the highest amount of salt in the system. And you can see this is at the wet season. It's going to be the lowest, and then it slowly builds up to where we are now. So this ends actually last Saturday. Okay, so I just decided, kill it at the end of the month. This gives you an idea of the long-term patterns for watercolor in the northern network. And if you were to take a look at this and then go back real quick, you would see it's almost like a mirror image. Okay, and so what this is a measure of CDOM, or watercolor. So most of you know that when we got a lot of fresh water, one of the first things that happens, the lagoon changes color, right? It gets very dark, gets very brown, and that is because the CDOM is actually, think of when you make tea, and you put a bag of tea in the water, and things come oozing out. Those are tannins. The same thing happens in fresh water when you have vegetation, either aquatic vegetation or terrestrial vegetation that gets in. It's a natural decomposition, okay? But that CDOM is actually one of the big attenuators for seagrass in the lagoon. So that's one of the reasons I'm interested in it. So actually the patterns here are highly coupled with freshwater discharges. And if we look at the local station for the last year, you can see, again, dry season, the water is clear, right, as it is now. Dwayne mentioned that, how clear it is right now. And then we have this big pulse of fresh water. Voila, what happens is we get the watercolor greatly increases. And then it slowly will decline during the dry season, where we are now. This is, again, all 4 stations, 5 years of dissolved oxygen. And you can see there's quite an annual cycle of dissolved oxygen, okay? And it's highest this time of the year. It's highest in the wintertime. That's primarily because it's colder water, and colder water can hold more gases, including dissolved oxygen. Let's just take a look at our local station for a year. It doesn't vary all that much, okay? Again, we have that same overall pattern, but I think what's the most important for you all to know is this is, I drew a line here for 3 milligrams of oxygen per liter. 3 milligrams, it's about when fish start to be stressed. Fish die when they get down to about here. So really the good news is, unlike what we saw in Brevard County where there are massive fish kills due to low oxygen caused by a decaying algal bloom, in this whole period, actually if you go back, I didn't draw the line for you, but if you go back, you'll see that this whole part of Lagoon does not have that low oxygen problem. That's your really good news. And of course, one of the reasons is we're close to 2 inlets. This is phosphate. So phosphate, as you know, is a nutrient. Nitrate is the other one we measure. And if we take a look at our local water, you'll see that it doesn't really have a huge pattern. It kind of is fairly consistent through time. It's not actually excessively high, but of course we'd like to see it lower than it is right now. Also, a real practical use that you might be interested in is just knowing about tides and water levels. So you can also use the data for that. You just go in and look at the depth, and it tells you about tides. So if you look long term for just our station in Vero here, you can see that there's a seasonal pattern. Those of you who live by the water, who fish in the water, you know about that. You know that the water levels are always highest in the fall, usually around October. You know, nowadays we talk about king tides, which is not really a scientific term. It's kind of been overused, but that's when that happens. And it's actually, you know, a significant variation in water depth through the whole year. And then again, this is the last year, just showing what happened the last 12 months. But if you want, you can also just go any increment you want. So this is the last week. And so you can see the ready high and fall. So a lot of times people say, you know, we don't have tides in Vero. No, we do. They're not as extreme, of course, as they are by the inlet. But you can measure this. You can monitor this readily, easily. I wanted to talk about what I think were probably the most significant events that happened in terms of water in our part of the lagoon. Was we had 2 storms, Matthew and Irma. And I call them hurricanes, and they were called hurricanes. And you remember both of them were supposed to impact us more severely than they did. So you might say, well, what were the impacts? Remember, this is just a tropical storm. You know, someday we will have that big storm here. And I think having these type of data will be incredibly valuable, because I believe, as do a lot of other scientists, that when you have these unusual events, these extreme events, they may just take a couple of days in duration, but their impacts can last for a very long time. And that's why we need to have these data. So meteorologically, and I'm just showing all the weather station data here, the 2 storms side by side, we never saw hurricane winds. We only saw, which would have been not even a serious tropical storm. It was, you know, about 50 miles per hour sustained in both hurricanes. And you can see that Irma, the sustained winds, lasted longer than they did in Matthew. Those of you who are here, Matthew came through, kind of, you know, did its little twist right before it hit the coast and then went to the north of us. And Irma basically went to west, but was much more slow in its passage. Storm surge, you know, those of us who live in Indiana County or live along Lagoon, I had never thought about this when we started putting weather stations in there, but I got a lot of interest, like say from St. Lucie County. I had one of their hurricane managers contact me and say, how can we use your data to understand what's going on with these weather events? Well, I said, well, you can look at that and you can see how much surge there actually is relative to predictions. And so you can take a look at this and you can see this little blip here. That's the storm surge. Matthew, it was relatively minor. And in Irma, it was a little bit more. It was 2 to 3 feet at several sites, but it was depressed around Sebastian Inlet. So this is actually Sebastian Inlet. You can actually see the water moved out of that area and probably moved down here. So that was all because of the storm, wind speed and so on. And this is precipitation. Matthew was not a very wet storm. Irma was a much wetter storm. And so we had really significant rainfall. So one of our stations, for example, in Jensen Beach had 16. The one at Harbor Branches, which is the closest one to here, had about 13 inches of rain during that event. So if you're up north and you want to know what happened back here, all you got to do is look it up. That's what we do, is we're watching the storm come in. We're also curious if it's going to blow away. our stuff, but it's something that you all can do. In the water itself, what was the biggest impacts? Well, turbidity. As mentioned earlier, turbidity is all those little tiny particles. And you can see this is Matthew, this is Irma, it's on the same time scale. And you can see that both of them had this huge increase in turbidity, but it was much more sustained by Irma. And the reason for that, looking at the meteorological data, the wind data I just showed you, is because the wind was that much more sustained. The absolute magnitude wasn't, but it lasted longer. Hence, we had a much greater suspension of particles, and it took a lot longer for them to recede. Now, if we look at the southern network, this is 2 years of data. I'm trying to show you the impacts of the hurricanes here. And this is where Lake Okeechobee comes in real quick. And when Lake Okeechobee comes through, you can basically see there's a huge decline in the system. You see it even better with Irma. Basically, it becomes like a freshwater lake. So the saltwater estuary becomes a freshwater system. So that means the oysters die, the seagrass dies, the fish can usually flee, but everything else has a serious problem. It also shows you what happens in between in this really dry year. But one of the things I really wanted to mention too is a lot of times people ask me, well, how about Vero Beach? Every time Lake Okeechobee discharges, isn't that bad for us? Isn't it impacting our water? The answer is no. 91% of that discharge goes straight out the St. Lucie Inlet. 9% moves up toward Fort Pierce and goes out that inlet. So we are not impacted. We're fortunate. We're not impacted by what goes on in Lake Okeechobee. And a lot of times people don't understand that. This is the same kind of thing that I just showed you for the south, for the north, for the south, and I'll now show you for the north. So you can see we also had declines in salinity at both stations, and we also can see during this period of dryness, this is much elevated salinity. These numbers here are all the freshwater discharges, by the way. So you can look at it in terms of precipitation, but you can just look at how much water is coming out of these freshwater canals. If I just zoom in on that, this is what happened during that hurricane in 2016, Matthew. The salinities, you can see, just went way down, but it was very short. It was very brief, just a couple days, and then kind of went back to normal. The following year, you can see a much longer period of time when salinities were depressed. So it was a much longer reduction in salinity, so it had a bigger impact. And then this is just looking at the southern salinities, just to talk about, again, since I started to talk about Lake Okeechobee, you can see how much longer the impact was there. So, good thing we're not impacted by Lake Okeechobee because it was 3 months of low salinities in the lagoon down there, okay? So it's really very, very different here. So I can summarize this real quick. These two storms that I'm talking about were only medium tropical storms. Overall, their impacts on water quality in the IRL and the St. Lucie estuary were pretty similar. There was this large turbidity pulse and the longer duration. And obviously, if we had higher intensity winds, the bigger issue that would be, and that would be very detrimental for seagrasses, at least on the short term. And I mentioned the salinity and the fact that Lake Okeechobee impacts to the south are much more severe than anything that we experienced here locally in Indian River County. And I think that, I think most of us realize that we're going to have, what the predictions are, is we're going to have more cases of extreme events, meaning we're going to have more storms, but we're also going to have more droughts. So things are going to get a lot more erratic in terms of what's going on in our environment. And again, to better understand that, I think these types of data would be, invaluable to have. Speaking of droughts, I showed you that there was a drought in 2017, and perhaps you remember that, and there was concern about wildfires. Some of you have been here a long time may recall a period of time, like in the 90s, where we had some very serious wildfires. I-95 was shut down for a while. You might remember even further the Everglades times when it kind of burns and we still get the smoke all the way up here. And you can easily get these data online to see how severe the drought is. So this was in that April 2017, near the peak of the drought. And the bottom line is it was the whole peninsula up to north of Jacksonville almost was very dry. So what does that do for salinity? Well, just focus in on that. This is what it was in 2016, which was a wet year. You can see the numbers are right here. And when we go to a dry year, you can see how much higher our salinities are. This again is to the south, so it's more extreme. But you can see huge differences from year to year. And that's why we say you can't really predict what's going to happen in terms of harmful algal blooms or fish kills and so on, because there's so much variability in the system. For our part of the lagoon, this is the wet year. You can see salinities are up and down a lot more. They're overall depressed, but during a dry year, everything is a lot more elevated. Both of these are probably more extreme than what we would ideally like to see in the estuary. Estuaries have lots of salinity fluctuations, but sometimes the extremes are more detrimental than we would like. So there's a lot of climate-related interannual variability, which I think we're going to get a much better handle on. And I can just kind of summarize by saying that having these data I think is really important. There's all these events. I'm really focused a lot on freshwater discharges, droughts, storms, algal blooms. And I would say, just like I may have overwhelmed you a little bit with all that data, one of the biggest challenges that I think we have on the scientific side, trying to collect all this data, is here you are, and you want to just know a little bit of information, and you don't want the whole fire hydrant coming out on you, right? So part of what I think we need to do, and we're trying to work on this, and we're going to make a lot of modifications in how we're delivering our data in the very near future, and that is to kind of realize we've got lots of different users out here, and try to have products that are more relevant for the layperson versus the scientist, for example. And that would be like better visualization of the data, so you can get more of a snapshot view of what's going on and how it changes through time. And we need to translate our stories better. And I've tried to do this a little bit. I do these blogs every now and then, post them on our website. So if you're interested, you can just go to, again, just Google Harbor Branch IRLO, and it shows right up. And I have to thank a lot of people who've helped me. This are the ones who've helped the most. There's others. All of our funding, a lot of our fundings come from the license plate, the shark plate, the Save Our Seas plate, but also the DEP supports the work in the St. Lucie estuary. Both the plate and additional funding has been provided by Harbor Branch Oceanographic Institute Foundation. So I'm really thankful for them, and they've been very encouraging. So I don't know where I am with time, but if you want, I can tell you what's coming next, or I can skip that part. No, go ahead. So I call this IRLON 2.0 for short. It's got a fancier name. But I had an opportunity recently basically to try to address some challenges that we have. Most of these things behind the scene that really would be really hard for me to explain. But it has to do with just trying to improve a number of things we're doing. So we've been working on doing that, and we are also, most importantly, what I want to tell you is that we're going to add new sensors for additional technology. And actually, I rely a lot on what the NEP folks do in terms of their planning, and I am on the, I always say technical advisory committee, but whatever the committee that's responsible for the science side of things. And one of the things that keeps coming up is historically we have not been faced with these harmful algal blooms. We need to understand them better. We need to know more about them. And coastal acidification. So without spending a lot of time on it, a lot of you know about ocean acidification. It's the reduction of pH, and that all is because of the fossil fuels combustions that we're doing. The CO2 in the air, that gets in the water, and it changes the pH. And it has substantially changed the pH, and it's going to continue to decrease. That has impacts, especially on things that are calcified. So for the lagoon, think clams, think oysters. And those of you who know anything about the clam business know that it's gone through an incredible decline in the last 15 years or so. So a lot of people say, hey, what's going on with that? Do we in fact have a lot of ocean acidification going on in our estuary? So that's called coastal ocean acidification. And there's very few people that are really measuring that. So our plan is to start to do that in the near future. Don't worry about all this technical stuff. But basically, we're going to measure the accessory pigments of things like the cyanobacteria that's responsible for blooms to the south, and to some extent is present in the northern part of the lagoon. And we're also going to measure additional parameters along with pH that we currently do that will give us a better idea of how serious is ocean acidification in the lagoon. Do we need to start to think about that? And how is it impacting, for example, the efforts to grow clams? And many of you probably know people who worked in nurseries for clams and have grown them out in nature. We're also going to try to do a better job, as I mentioned already, on our website. So, for example, some of this information I try to relay today, we can show, ongoing, what the long-term average is at a site. We can say, here's what is a typical winter scenario for the environmental conditions. Here's a typical summer. This is outside what we normally see. This is unusual. This suggests an issue. This is a problem, okay? Things like that. And then we've actually been asked to expand our network north into Brevard County. There are other folks that are doing real-time water quality management, including the St. Johns River Water Management District and also Orca. And so we would work with them to select where our sites would be. You can see there's some major gaps in current efforts in some of these areas. And we'll actually do this with something we did when we first set up the existing network, which is get about 35 to 40 people together from up and down the lagoon, discuss what we want to do, and listen to what their thoughts are, and then we can select our station and then go through the procedure of working with the Coast Guard and launching that. But what that will do is it'll for example, no one else has the ocean acidification capability, and we think that having that alone up in the northern part of the lagoon would be an incredibly helpful thing to do. If you're not a Yankee fan, sorry, we're close to Dodger Town. But the last words are Yogi Berra. You can observe a lot by just watching. That's what we're doing. This is ocean observation or Indian River Lagoon observation. And the more you can observe, it's probably a good thing. It worked for Yogi anyway. I think that's it. Yeah, questions? Yes, sir. Mean the different groups? Yeah. Okay, so the question is, has there been any discussion about merging databases, for example, our data with Orca's and with like the St. John's folks? The short answer to that is briefly, but there's another effort going on now, again, sponsored by the Indian River Lagoon National Estuary Program, and I'm heavily involved in that effort, to develop a monitoring plan, which basically would be to incorporate not just what you asked about, but other things that people are measuring, including biological stuff. And in fact, that's something that needs to be done, is to put all the data together and make it accessible. We had a workshop about this like 4 or 5 years ago, and now this current effort, I think, kind of grew out of that. But we need to do a much better job. There's a lot of data out there, so putting it all together and making it available would be a really good thing to do. Yeah, Gene?
I just wondered if there's any way to test what effect herbicides have on the seagrasses in the lagoon.
Yep.
Especially thinking about the use of glyphosate
Yep.
is used in the canals and empty into the lagoon.
Mm-hmm.
Is there any way to test whether that has an impact on
Yeah.
seagrasses?
So the question is, how might we be able to test for impacts of herbicides on seagrasses in the lagoon? There's been a lot of discussion about that. The current consensus is that they do not persist terribly long in the environment. There's some stuff in the literature that contradicts that and says no, we got to take it a little more seriously. It's not easy to do. And I think that's the reason why it's not being done routinely now. It's expensive, it's hard to analyze. All the spatial variability and temporal variability that we might have, to really do it right, it would take a lot of funds to do it. I have thought about doing it in a small scale, experimentally. That's not the same thing as doing it out in nature, though. So I think it's one of those emerging issues, and I know if Dwayne was still here, I think he could also speak to it, because he and I have talked about how big of how big of a problem is it, and shouldn't we do more to look at it? So I think the answer is yeah. It's definitely on the list of many things that would be good to do, but right now it's not being done. You know, it needs to be done, but how we're going to go from here to there, it's not going to be an easy thing, but it needs to be done. Yep. Yep. Yeah, so the question was, and it was a follow-up to the last question was, well, aren't other people in the world doing this, and can't we rely on that? And the answer is yeah. I mean, in science, we always rely on what other folks do as well. There's been a lot more work elsewhere. This thing I said about the persistence in the field, it's been very hard for people to find it. When they do it in the lab, that's where they find that it can persist a lot longer than what the current consensus is. And there has been experiments done, like with algal cells, phytoplankton, showing that it can be inhibitory. And if it's inhibitory to an alga, you would think then it could be inhibitory to seagrass. So yeah, that information is out there, but I think also the conditions are always different, because something like that, the persistence is going to depend on the conditions. So heat and salinity, for example, and how they vary would probably have a major impact on how long it would last. So I mean, it should really be done.
We appreciate that. And lastly, you mentioned salinity a lot
Mm-hmm.
today. And you mentioned that drought, that drop,
Yep.
that rose the salinity level so drastically for a period of time. How has that affected anything at all in the water?
I think that droughts per se are not, for most organisms, droughts per se are not a bad thing.
The salinity level itself.
Oh, just how in general salinity impacts things? Oh, okay. So a real basic question then. Okay, so basically the question is, how does salinity impact organisms? So, okay, so you know, if you look at most marine organisms, take the big picture, most things that live out in the ocean, only a small percentage of them can live in the estuary because of the reduced salinity. They've evolved to having a certain amount of salt inside themselves and outside, and they don't have the mechanisms to cope with reduced water. Basically, the cells will either expand or contract depending if they come from freshwater or saltwater. If you look at things that live in freshwater, there are very few things that can penetrate into the estuary. Most of them can't make it. There's some major exceptions. You probably know some fish that can go back and forth, for example. But that's because they have regulatory mechanisms that have evolved for them to do that. So most organisms have a certain range of salinity which they'll grow in. If it gets too high, too low. I mentioned in Lake Okeechobee discharge situations, when it becomes a totally freshwater system, there's very few things that grow in the estuary that can tolerate, you know, zero salinity for, you know, months. I mean, most of them, it's, you know, days to a couple of weeks.
I would imagine, I don't know if it's factual, but with us being in proximity so far apart from both inlets, that means the ocean, that our salinity level is probably a little lower in this area than it would be closer to the inlets. Would that be correct?
In general, yes. There's a salinity, in general, there's a salinity gradient between here and, say, Fort Pierce Inlet.
Our species, therefore, I guess, would be accustomed to this salinity level.
Right.
Any question would be for whoever, if there is a culvert, if that culvert would bring in salt water, how would that affect the species that's in the...
I think that's a huge question, and I'm sure that Dr. Zerillo, I'm sure that's part of their, I know it's part of their plan is to do these what ifs. I mean, that would be, I think I would defer to him on what his thoughts are going to be. I don't want to steal his thunder, but I think that's a serious question and needs to be considered. That salinity gradient, though, to get just one more point on that. So that's one of the reasons, if you look at like what grows, say in the right here in Vero proper, and you go down the inlet toward the inlet, you know, you get much better seagrass beds as you go further away from the fresh water. You get higher diversity of the inverts that live in the lagoon into the seagrass. So there's a lot more life, a lot more biodiversity, if you will, down by the inlet than there is far away. Yes. Yeah. Exactly. Yeah. 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 And the other thing is, you said how far away we are. Well, the people who are really far away from the inlet are in Brevard County, and that's one of the big challenges, and that's why those blooms are up there and they stay there. It's because there it takes maybe a year or two even for a drop of water to go from there out an inlet. Whereas right here, it's probably 5 days at most from where we are right here. Okay? Thank you.
Great, thank you. Thank you, Dr. Hanasek, and he has in the past, he's appeared a number of times at my programs in the past, so I thank him for his continued support on sharing information on the lagoon. Our third segment is going to be a little bit longer than the other two, so I'm going to say let's take about a 7-minute break, and then we'll change up here, and then we'll be ready to start when you get back. So, thank you. minute? Yeah, he's going to make just a few comments as the next speaker is going to be coming up here in a minute. Part of the reason I did this in the order was, one, give a little baseline what's going on with the lagoon. Some of you have really keyed in that one of the things that has always been brought up regarding a flushing connection is the salinity. How do you manage it? How do you monitor it? How much is too much? How much is not enough? So having Dr. Hanasek kind of go through that to show the aspects and all the different things that affect the salinity level, which is very important because to me that's part of one of the make or break pieces of data that can either support a flushing connection or not. Just a little bit of a short history. Back in 2010, I was made aware of the Destin Harbor flushing connection, where they had a similar environment. They had a water body with a dead end. They had Highway 9 that dropped a lot of water from the highway system into Destin Harbor, and they really had a water body that was not flourishing and had very little bit of marine life in it. And they went forward and funded they just went all in and just built it. Probably at that time I'm going to guess it was about a $10 million project, but, and in the beginning it was run 24 hours a day, 7 days a week. And now Destin, when they run it, the water quality's improved over the years. The fish have come back. It's a great success story. And now it's more of run on maintenance, as certain water indicators indicate certain levels of whether it's the salinity level or the other things they monitor. Then the system comes on more as a maintenance. It's not run 24 hours a day, 7 days a week again. So from that point on, I became an advocate for Bethel Creek, knowing the history of it. Not saying my mom's age, but my mom's in the back, and her family came to the area in 1914. And we've heard, as growing up as kids, the stories of different parts of the Interannual Lagoon that would open up back to the ocean. And some of the early photographs that I have from the early 1940s from the military that show what the area of Bethel Creek looked like versus what it looks like today are quite dramatically different. With that, we'll go ahead and bring up Dr. Gary Zarillo from FIT, who will be doing our third segment here today. We'll give him a warm welcome. Great, thank you. Thanks for coming.
I would like to start with two disclaimers. Number one, I will not specifically be talking about Bethel Creek because we are in the middle of that study, which is to be completed by June 30th, 2020. Number two, we are not running any water quality simulations in this phase 1 study. That may happen if there's a phase 2. So we're largely considering circulation, hydrodynamics, and transport of heat and salinity. So we will be looking at salinity regime as versus some of the scenarios that I will provide an overview for you today. So restoring lagoon inflow, we have kind of a cast of thousands, several, 6 or 7 faculty members at FIT. Project was funded by the state legislature. Money comes down through the Florida Department of Education, which is a good thing. And so today I will give you an overview of our project, including hypothesis, and I'll talk a little bit about the methodology and provide a couple of examples of where we've already run simulations of exchanges of water between the coastal ocean and the Indian River Lagoon. So the focus is largely today going to be on the North IRL, particularly the Banana River, which is a poorly flushed compartment of the IRL system. So it's not advancing. This historical set of the full view and a zoom view on the right were handed to me a couple of months ago with our hypothesis at the start, which has some key words in here which I think are important. Controlled water exchanges between the IRL can be engineered to provide improved flushing and perhaps water quality within local compartments of the IRL without a negative impact on littoral sediment budgets that could be linked to a permanent inlet. And so I think the concept of controlled water exchanges is important. There have been attempts in opening up the IRL system in the historical record. Gibson's Cut is situated where the current, more or less where the current location of Sebastian Inlet is today. I think that's probably 1889, something like that, and that was an initial attempt. Place Pepper Hallover apparently is a human anthropogenic cut made maybe before the beginning of the 20th century at the north end of the Banana River. So there have been attempts at providing these cuts across the barrier island, barrier beaches into the IRL. And the reasons for these is unclear, but anecdotal information indicates it's largely to provide clearer water, in some cases maybe navigation from the estuary into the coastal ocean. So there's historical precedence for this. These are our milestones. You can read through them. We're doing biological surveys, hydrodynamic simulations, predictions, assessment of likely biological, physical, and chemical response to a pilot scale inflow. We're working entirely within the virtual world now. Phase 2 might include a near full-scale pilot experiment, and my colleague Robert Weaver, who's an ocean engineer, coastal engineer, he and his students will be providing a 10 to 20% initial design based on our findings from the field monitoring portion of the project and the numerical simulations. So it's a broad spectrum study. We're trying to look at all aspects from flushing characteristics, biological, ecological, and chemical responses. This might be the most important part of this discussion, natural inflows to the Indian River Lagoon. This is something that is not, I think, well understood by the general public. And we've received a lot of criticism, or some criticism, that we really shouldn't be looking at this because it might de-emphasize the need to do things in the watershed, but nothing could be further from the truth. I think what we're looking at here is potential, maybe the term is geoengineering, to mimic or reestablish some of the natural exchanges between the estuary and the coastal ocean. Some of you who live over on beachside here are likely to live on something that I call the storm surge platform. Storm overwash and inlet migration zones. This is showing the northern end of the central portion of the IRL and the Banana River, Satellite Beach, South Patrick Shores. And you notice that the barrier island kind of widens out in some of these areas. So historically and prehistorically, there would be storm overwashing, storm washover fans of sediment, temporary breaching by tidal inlets, and the tidal inlets breach. And uncontrolled, they will migrate along shore, generally from north to south, under the net littoral drift up near Cape Canaveral. That migration might have been from south to north in the shadow of the Cape. Anyway, the widened sections where we put all our human infrastructure on essentially is there because of storms, inlets and storms. If you look at the historical literature, the early textbooks on coastal morphology, you don't really see the term barrier island. What you see is storm-washed islands. And I can't really find where the term barrier island comes into the picture, but I suspect it's probably the real estate industry. So I do have a message here, and I think this is an important thing to consider, that naturally there would be exchanges between the Indian River Lagoon, Banana River, and other estuaries of the like between the coastal ocean, and it would be fairly frequent, maybe several overwashes during the year, temporary inlets that might have a lifespan of a few years to a few decades. It's all part of the natural process that we have, by and large, stopped in its tracks. What can happen during the storm and how these exchanges take place? This is post-storm conditions, south coast of Long Island, 1938 hurricane, sometimes called the New England Express. And it impacted a large section of the east coast of the United States, especially New Jersey, Long Island, and especially up in the Providence area of Rhode Island. And so this is what could happen in a Category 4 or 5 storm. The lower part of the image is the Atlantic Ocean. On the top of the image is the bay or estuary in this case, and you can see a lot of storm overwash fans. You see new tidal inlets being cut by this particular storm. We haven't seen this here in Central Florida in a long time. Maybe not within the historical record, although there have been some major storms that have caused this kind of change. This looks like it's very damaging, but this is how barrier islands operate. They require occasional storm overwashing to help them build and maintain their pace with rising sea level. They're going off on this a little bit. Post-storm conditions, Miami, 1926. I don't think anyone here remembers this storm, but it was quite devastating in South Florida, and some say it brought on the initiation of the Great Depression a little bit early. It happened about 1 year after the real estate collapse in 1925. You can recognize Mexico City Beach, pre-storm, Mexico City Beach, post-storm. It looks like Nagasaki after the nuclear weapon. In fact, hurricanes, really large storms, have many times the energy of a small nuclear explosion. So this is what could happen. And under these kinds of scenarios, we do have exchanges between the coastal ocean and the estuary. Looking further to the south, a bit north of where we are today, Sebastian Inlet area. Sebastian Inlet, of course, is an anthropogenic tidal inlet. It was cut into the underlying coquina, dug and blasted in the late 1940s. However, there are relic flood tidal deltas, flood shoals, marking other similar inlets prior to the present version of Sebastian Inlet. To the south of Sebastian Inlet in North Indian River County, we have a storm overwash and inlet migration zone. So if you know how to look at the morphology, you can see the inlet scars, you can see the overwash fans, and all of our infrastructure, residential areas are largely built on this storm-developed platforms. So it's not unreasonable to consider, well, maybe we should reestablish some connection between the coastal ocean, controlled, episodic, just like storms to help improve flushing and perhaps improve the water quality. So that's the basis of the thought. We are preventing this kind of thing by, this is a good thing for tourism, it's a good thing for the economy, restore the beaches, big projects here in Indian River County, Brevard County. So we are anthropogenically engineering the barrier island systems not to provide this natural exchange between the coastal ocean and the estuaries. And so we are working at cross purposes between maintaining the health of the Indian River Lagoon and similar estuaries and the health of our economy and beaches. So we need to find an area in between to try to work both sides of the coin. This should self-ignite here. This is shows an area of North Carolina. Maybe we can get the animation to run. I'll run it a couple times. And it shows how natural barrier islands actually operate. It's about a 20-year animation developed from sequence of historical photographs from Google Earth. And you can see a new inlet opening up on the northeast, opening up. And you can see development of the flood shoals. We're just ticking through the years. Storm comes along, opens that inlet. It migrates along shore for a while. After a few years, it closes up. The inlet, the larger inlet to the south actually increases the size of its flood shoal as it develops over time and also migrates to the south in this case. This is a section of the Outer Banks, North Carolina. This is how barrier islands, so-called barrier islands, operate. And again, they require this processing by tidal inlets to maintain their balance and their health. And in doing so, they also provide some flushing and renewal and exchanges, strong exchanges between coastal ocean water and estuarine water. It's a healthy thing. It's functioning as it should. So that's some background. So numerical model experiments, I'm here to talk about that. And the illustrations that I provide today are largely based on simulations that we've done over the last 4 to 6 years. And in this image, you see 2 white arrows, one sort of in the Port Canaveral area and one in South Patrick Shores, just at the north end of Patrick Air Force Base. And I'll show you some of the early simulations that we did in a simpler model than we're using now to show you what possibly what this controlled water exchanges between the coastal and ocean and the estuary might result in. And the ways these experiments are created is that you have a numerical model, has a series of cells or boxes that exchange information, and we can tag the water particles with a numerical dye of some concentration. In this case, it's 20 parts per thousand. And then as the simulations evolve, and I'll show you simulations that extend over about 12 months, you can see the dilution, if you will, or the flushing of the numerical dye from the various compartments of the Indian River Lagoon in sequence. And so as shown here in the vertical scale, the legend, we have the dark red color, 20 parts per thousand, and the cooler colors indicating no concentration. And so we have several sources of untagged water, if you will, coming into the estuary. One will be in the, let's get back to where it was. One will be a major one here at the south end of the image near, or at Sebastian Inlet. We'll add some water here. We'll add some water here by different mechanisms. We also have some fresh water coming in the major tributaries, as well as watershed inputs, which are in the present model that we're using, but not necessarily in this model, other than the tributaries like Turkey Creek, Crane Creek, O'Galley River, et cetera. So that's the kind of setup that we're working with. Here's the first example. So we have a thin section of the barrier island that hasn't been processed by storm overwashed or inlet breaching in quite a while. We have the storm wash and inlet processed areas just to the north, Patrick Air Force Base, and in the Patrick Air Force Base itself in Satellite Beach. We have the northern compartments of the Banana River, one of the northern compartments of the Indian River Lagoon. We have 528 here. Let's see, 520 here, State Road 520, and other, the barrier here, I guess this is the train trestle or one of the bridges going out to the NASA Space Center, which also kind of restricts circulation. But I won't be talking about the bridges or causeways. I'll be talking about the pumping station and looking at the possible result of adding coastal ocean water into the estuary at this point. So this is an example of one of the experiments that we could complete. A pump station operating 12 hours a day, pumping about 10 cubic meters or about 350 cubic feet per second, 12 hours a day. Seems like a lot, but let's see what the result of that would be, at least in terms of the flushing of our numerical dye. See if we can learn something from that. So I'll flip through these. At the end of this, I have an animation which I think is more informative. So on the left-hand side, we have existing configuration, not adding any additional coastal waters into the estuary, but just as the as-is case. And then on the right-hand side, this is the simulation after 50 days. If you look closely, you can see a little bit of flushing going on here with a reduction in the concentration of our numerical dye. You can also see quite a bit of flushing, clearing up of that initial pure red here in the southern part of the image, and this is largely due to a combination of water coming in through Sebastian Inlet, the Sebastian River, and then some secondary tributaries up here also aid the flushing in terms of our numerical simulation. So that's 50 days. And here's a zoom of that 50-day picture. And you can see some of the impacts of that 12 hours a day, 10 cubic meters or 350 cubic feet per second coming in. You can see the signature of that pump station. And of course, you don't see it over here on the left-hand side because it's closed. There's no exchange. So we'll flip ahead in time in this model test to 100 days. And you can see the situation is changed pretty dramatically on both sides. We have a lot more flushing here up towards the northern compartments of the IRL. The animation will give you a better picture of how this occurs. You can see the impacts of the signature of the pump station here, kind of get this mixing zone here between the ambient water and water coming up through Dragon Point at the south end of Merritt Island. But take notice in both cases, existing and the pump station case, the northern compartments of the Banana River are not showing much response. At the end of the simulation, you'll see that the Banana River, at least in the numerical model simulation, flushes very little even after 360 days. I've been talking about this with some of my colleagues at the St. John's River Water Management District, and we're talking about maybe the flushing time here is something on the order of 1,000 days or something like that. So after 100 days, this is the zoom picture, and you can definitely see the signature of that pumping station, and its impacts here are kind of confined to areas south of State Road 528 and State Road 520 crossing the Banana River out to the barrier island. Our pump station is here. Again, you can see the flushing here from the pump station and also water excursioning into the area from the IRL through Dragon Point, that connection between the IRL and the Banana River. Again, that kind of mixing zone in here. So there's definitely a recognizable impact. But the other areas look pretty much the same. 200 days, advancing the simulation. You can see a large portion of the northern compartments of the IRL seem to be more or less clear of numerical dye. We can see that the Mosquito Lagoon, which is a very important part of the system, and you have to include it in the simulation, has some pretty good flushing action through Ponce Inlet, but the southern compartment here of the Mosquito Lagoon is poorly flushed. We've actually run a water quality model in this area, and you can see some algal blooms in there occasionally and high chlorophyll content. And our pumping station continues to do its job. And 200 days, the zoomed version of this. It's hard to see a big difference between the two. There's lower concentrations of numerical dye in the southern compartments of the Banana River. We still have high concentrations of the dye in the northern compartments in both cases. We get to the end of the simulation, and this is pretty interesting in both the existing and the pump station case. After 1 year of simulation, 366 days, it was a leap year, you can see that there is some flushing of the numerical dye from the Banana River, the northernmost compartment, which is easily seen here in the zoom view, has some reduction in the dye concentration, a bit more than the existing case, even in that northernmost compartment. But compared to the other compartments of the Indian River Lagoon system, not well flushed at all in this simulation of its numerical dye. One of the reasons, of course, is that it's enclosed. There's no intersection, there's no connection with the coastal ocean that was terminated with the advent of NASA, I think in the late 1950s or maybe in the earlier part of the 20th century. So let's just run through the numerical model in terms of a simulation. This is encompasses most of the model. There's a lot to be seen here. You can see the tidal action up here in the northern compartment of the Mosquito Lagoon, but that tidal flushing is kind of restricted to the northern third of it. If you look closely, and you'll see more in the zoom view of this, there are exchanges across the barge canal opposite Port Canaveral into these compartments. You can see some of that high concentration of dye moving up into the northern compartments and even crossing in to the Mosquito Lagoon. So that's the end of the simulation in the large scale here. And this is a good comparison here. This is we see the very end of the simulation for the pumping station and then kind of the beginning of the simulation for the existing condition. So it shows you most compartments are flushed, and even with the pump station, the Banana River doesn't undergo complete flushing of the numerically tagged water parcels. So I'll run the zoomed version of the animation, and you can really see that pumping station doing its job here. You see some sloshing back and forth pattern in the animation, and that's of course because the northern compartments of the IRL are largely driven by wind stress. The changing of the wind direction will reverse the currents occasionally. There's another factor that helps flush this that most people don't understand, and I can show you an illustration of this process later if you like, and that is the change in the sea level of the coastal ocean, which completely penetrates into the estuary, is on the order of 2+ feet of rise and fall every year, driven by variations in the flux of the Gulf Stream. And that does help to flush the Indian River Lagoon and all of its compartments, but it's at kind of an annualized scale. Here's the second scenario I'll show you, and this is a simulation we ran some years ago, and this is a weir structure at sort of the west end of the Port Canaveral complex. It's about a 100-meter wide weir, and it's set at an elevation to allow only flow to cross the top of the weir structure during high water levels. Of course, the port is tidal because it's connected to the coastal ocean, has maybe a maximum tidal range of up to 3 feet, and so high tides, of course, with the weir here will force water over the top of the weir and into this compartment of the IRL. One of the issues with this, of course, is that it increases flow velocity in restricted areas and even in the port itself, so it might be an undesirable or unmanageable effect having increased flow velocities in the port because of navigation. And in this restricted area where this narrow bridge is, the velocities get to be pretty high, and also across the weir structure. And you can see sort of the plume of water here marked by the vectors that show the flow velocity. But anyway, it's an interesting hypothetical, interesting mind experiment. This actually has a lot of impact in terms of flushing because there's orders of magnitude higher volume of water coming across that weir than you can pump in a 10 cubic meter pumping or even a 20 cubic meter per second pump station. And so even after 50 days, we get quite a bit of flushing in the compartments of the Banana River. We don't see it in the existing case because the port is largely sealed off from the coastal ocean except for occasional openings of the water locks, and they let volumetrically the flow across there is very small even when it's open. So here's the zoomed version of that, and you can certainly see the effects of that hypothetical weir at the west side of Port Canaveral. It's flushing these compartments pretty well. That's just 50 days. Fast forward to 100 days, and you can see some interesting things going on in the model. Of course, the existing case where we don't see much flushing at all, as usual in the northern compartments of the Banana River. Here, with this water coming in from the coastal ocean, some of it is being moved north by the flow in winds, and it's really flushed out those northernmost compartments. South of the Port Canaveral, you get this mixing zone in a sense where it's forcing the water to the south, and it's beginning to mix with water from the ambient IRL, which is now pretty much clear of numerical dye. And so we get this mixing zone here between the ocean water and the IRL water, as well as flushing the northern section of Banana River. And there's other things to be noticed here. You can also see, as usual, some flushing at the north end of the Mosquito Lagoon because of the presence of Ponce Inlet. Zooming in on that, one of the interesting things I see here is at 50 days with the weir structure here, you can see maybe some differences induced by the circulation. Over here in the existing case, we have some clearing of the numerical die in this compartment, and although it's out of the picture a little bit, a little less clearing here. Well, this is pretty clear, so I guess it's about the same. So we have this dispersion of the numerical die in the Banana River compartments, and we don't really see that equivalent under the existing condition. And then 200 days, again, pretty well flushed the Banana River except for this mixing zone. Flushing of the Mosquito Lagoon, flushing of most compartments of the IRL, but a bit more flushing here, probably as a result of some of that water crossing the barge canal and getting into the northern compartments of this section of the Indian River Lagoon. And then the zoomed condition at 200 days, again, kind of business as usual. 366 days, everything is clear in under the existing condition with maybe a few parts per thousand of the numerical die. Again, we have these higher concentrations of tracer remaining in the compartments of the Banana River. And over here on the weir test side, things have cleared up almost perfectly in the Banana River compartments, except for this mixing zone, which is a persistent feature. But still, the tracer concentrations are low. And the zoomed version of that, making the comparison. So you can really see how this is working in the animation. And I think your eye can track the difference pretty well. We'll let that run to the end of its 366-day time period. Again, a little bit of that sloshing of the water masses north and south under wind forcing. So that ends the simulation. Then we'll do the zoomed version of this. So immediately you can see the water coming in across that weir under tidal forcing. So there's no pump station involved in this case. It's just the elevation of the coastal ocean gets a little higher than the IRL, and that forces the flow of the untagged water across the weir into the central and northern compartment of the Banana River. You can see over here some of that dye coming across the barge canal and flowing to the north. Let me just replay this guy. To back up a couple slides. You can see that barge canal connection across. And occurs under both cases. So for the Bethel Creek area, we will run a pump simulation, and I will experiment a bit with the volume of water and the timing of the exchanges. Could be 12 hours, could be 6 hours, could be 6 hours on, 6 hours off. So you can expect to see results that look something like this in a general way for the Bethel Creek area. So we haven't made any project recommendations, but it could range from pumping stations, probably just going to be a pumping station, maybe some kind of weir structure, but unlikely to be under the present version of Port Canaveral. There's some other technologies out there, the same technology that the Hawaiian Islands use for air conditioning, exchanges between their ocean and the interior. Something like that could be thought about almost like a thermal exchange. One of the early experiments that we ran was a temporary flushing inlet, just a narrow, relatively shallow inlet here cut across the south end of the barrier island of the Mosquito Lagoon, and that experiment, which we did maybe 4 or 5 years ago, was fairly successful. So you'd open that temporary connection. Sometimes nature opens a connection right about here, let it stay open for a while, and then close it. Another possibility could be a series of culverts. The St. John's River Water Management District has done a study looking at a series of tidally forced culverts. And I don't remember the exact location of that, but Chuck Jacoby can tell us. I think it was in the interior of Port Canaveral. I will also experiment with that in the numerical model, which has the capability of programming into the model grid culvert structures and organizing the timing of the structures with various stages of the tide or just mechanical opening and closing. Here, I think this is an example from somewhere in New Jersey, and it's not connected to the coastal ocean, but to another water body across this roadway. And so with rising tide level in the adjacent water body and the flow, hydraulic head difference, creating a flow through the culverts, and the counterweights here cause the culverts to open. And then when the tide reverses, the reversing flow in the other direction will close the culverts. These kinds of structures could be operated on a time schedule. They could be linked to measurements of water elevation in the coastal ocean, in the Indian River Lagoon. There's lots of engineering that could be accomplished for this kind of connection. Again, just talking about the exchanges between the coastal ocean and the estuary. This is one of my favorite places where I've been an observer, both casual and scientific, for over 60 years, Seaside Park, New Jersey. So one of the solutions to shore protection and coastal resiliency, of course, is to protect the barrier island and the beach at all costs from overwashing and breaching and storm impacts. However, it may get you from another direction. This is actually G Street in Seaside Park, and we're looking at a completely artificial dune, as we have here in Florida. Most of the dunes, or all of the dune structures in New Jersey, are completely artificial. There is a nice setback of the real estate here, which is good, but if you stand at the end of the east end of G Street, right about here, and do a 180 and look towards the bay on the other side, you'll see something like this twice a month. This is called nuisance flooding. Have you heard that term? You might even expect to see some of it in Indian River County. This area, it's driven by the tides because sea level has risen by almost a foot in my lifetime in this area. I'll show you some data. And the seawall here is pretty low. And so on spring tides occurring twice a month, you get flooding. And notice the new construction here. This is image taken in October 2019, a few months ago. Since that time, I've been back there. The structure is almost complete. This piece of property, here's another point, again, kind of on my soapbox. There was a house here that was largely destroyed in Hurricane Sandy, which completely overwashed this section of the barrier. And this property was purchased in 2017 for $370,000. The old structure was destroyed, and the new owner built a new house here. And the size of the lot is not much bigger than this room. And I asked the owner, I'm kind of doing an informal survey, why would you want to invest $1 million or more than $1 million in an area you know is going to be flooded at least twice a month and possibly destroyed in the next major storm? And he couldn't answer the question. In fact, he just lost his mind. He got mad at me. No, it just does not compute. On the other side of New York Harbor, Rockaway Peninsula, New York, the same thing, lots of nuisance flooding. It's an ongoing problem. Here in Florida, of course, we're seeing more and more of this in Miami to Fort Lauderdale, which is now the Venice of the West. And this is germane to our project here, the Flushing project. This is the sea level record with the tides filtered off of the NOAA tide gauge situated on Sandy Hook, New Jersey, facing New York Harbor. And it's about a 90-year record. And it's about a foot of sea level rise in 90 years. My cognizance of this area goes back to 1954. Hurricane Hazel, 1960, Hurricane Donna, the Ash Wednesday storm, 1962 is right about here, and then Sandy. But you can see that we have the trend of rising sea level, and then from year to year, there's a lot of interannual variation in sea level. So sooner or later, we will get a natural connection, albeit temporary, between our coastal ocean and the Indian River Lagoon. I hope it's not this year or next year or any year, but it's going to happen at some point. And because of sea level rising at a fairly rapid rate, although there's not necessarily a sign of accelerating sea level rise, in your lifetimes we've had a half a foot to a foot of sea level rise, sooner or later it's going to catch up to us. Anyway, we can think about temporary connections to the coastal ocean. Kind of in this venue, it's a natural kind of thing to do. Historically and prehistorically, it's been prevalent. It's actually built the barrier islands for us, on which we put a lot of our geoengineering, if you will. So that's my presentation. I'll be happy to answer some questions, provide some answers. Yes, sir.
It appears that if you're gonna do it in the Bethel Creek, you ought to do it at the end of Bethel Creek and not at the Bethel Creek house, which is what your system is gonna do.
Yes, as part of the study, we will try to optimize the location. We, in fact, may run several simulations. The model is set up, it's running, so it's fairly easy to do simulations in rapid succession and look at the range of results. The question was a recommendation for a specific location of the exchange between the coastal ocean and the estuary at Bethel Creek. By the way, of course, Bethel Creek is one of those areas where the canals are actually taking advantage of natural tidal drainage that existed in the past. So you're all built on areas that have been recently, within the last few hundred years, overwashed and breached. Is there another question here? Yes, sir.
You made a correlation between beach restoration a few times in a project like this. And is this something that's tied into the purpose of this whole thing?
Yes, in a sense, because the designs that we're looking at and the scenarios that we're considering are arranged or designed, engineered not to interrupt the littoral flow of sediment. That's the major hurdle for putting in a permanent stabilized inlet. In addition to it being very, very expensive, you then create the problem of having to interrupt the littoral drift and have some kind of bypassing project to keep the flow of sand crossing the inlet, so the so-called downdrift beaches are not subject to erosion because of that permanent inlet. Well, you saw it in the animation, right, with that new inlet that was opened up in North Carolina. The first thing that happens, you develop a large flood shoal. On the seaward side, you can't see it, but subaqueously, there'll be an ebb shoal. And so over the years, they will expand in volume, taking a substantial amount of the annual transport of sand out of the system and placing that sand in the flood shoals, thereby robbing the beaches downdrift, in this case in Florida to the south, of sand required to maintain the beach and the shore face.
You mentioned lateral flow. There's a lot of lateral flow. Of course, we see it all the time how the ocean just sweeps to the south so strong in the wintertime especially.
That's right, and that's the reason that you have net littoral currents from north to south and littoral drift on an annual basis. It's a series of nor'easter-like storms, waves coming onshore at an angle, breaking waves create the littoral current, and a number of episodes of those high-energy wave events will force the net flow of sand from north to south. And you want to keep that moving one way or another. If you stop it, and that's one of the reasons we have so much coastal erosion. I think it was Bob Dean from University of Florida some years ago said that 70% of observed beach erosion is due to tidal inlets because of the interruption of the flow, and I think that's a reasonable statement.
So, sorry to take too much time here, but hey, comparing that now to that area in North Carolina, because I know the shoreline there is a lot different, and it's facing a whole different angle. Okay, so we're east, and we got east. Is that a relative, I guess, is it relative to the coastline that we have now?
Yes, it is, because if you look at the wave climate there, Even though the orientation of the Outer Banks or sections of North Carolina is not exactly the same as Florida in this area, still the waves coming in will refract and make an angle with the shoreline. The most important thing is that angle of the wave crest with the shoreline, not necessarily the orientation of the shoreline, but the angle between the shoreline and the dominant wave energy is the important feature that drives the net littoral drift. So that barrier island operates very much as our barrier islands would have in the past, processed. And you can see it in the inlet scars and the overwash fans.
So can you just explain finally what that would do to eliminate or the need for beach replenishment?
And the question is, what would that do to alleviate the need for beach replenishment? But I'm not sure I understand the question.
Right now, we're bringing in tons of sand, of course, to replenish the beaches. How would this affect that?
This project?
Yeah.
Not at all. Because we will, the pumping station, I haven't talked about the design. Robert Weaver will talk about that. But essentially, it's likely to be directional drilling underneath the barrier island, like directional drilling for oil and gas. And so the entrance of that will be a kilometer or two or mile offshore with a riser, and then you have the pipe coming into the estuary inshore on the estuary side, also with a riser and a cage. And so the littoral system is not even in the picture. It's not in the equation. Something like the St. Lucie power plant. If you look at that on Google Earth, you can see the large power plant, which itself is on a relic flood shoal, which is insane. But they have their intake and they have their outtake canals, and they pump water to cool the reactors. And so their intake is offshore, and it's quite an effort to maintain that. And then they circulate water into their cooling ponds, and then they circulate it out back. So, they did some directional drill cutting, placing the culverts, canals underneath the barrier. And if you look at that situation, the barrier island, the beach goes right across the front of the power plant, and there's no interruption there. This is just north of St. Lucie Inlet. There's no interruption in the littoral flow until you get to St. Lucie Inlet, which is a whole other problem. Yes, ma'am.
Beach restoration is very expensive and is a very long-term project. Will your project study, or future project study, where perhaps we might be less diligent, shall we say, with beach restoration and perhaps allow for washover at specific points along the beach?
So this is a very good question. So the question is, will our study address perhaps allowing temporary cuts through the barrier island at locations where there's less of an issue with the littoral transport? The short answer to that is no, but the long answer, if you look at other locations with similar problems, we do that on the south coast of Long Island, in some of these large coastal ponds. They cut through the barrier island several times a year to allow the ponds to flush and then close. So it's not unreasonable to think about that. But that is something that will take a fair amount of study and a huge amount of political maneuvering and permitting. If you could find a location to do that, it would be good. What I envision in the ultra long term will be a series of control structures connecting the coastal ocean with the Indian River Lagoon that can be operated on a schedule or at will when needed. Of course, that would be pretty expensive, but it would not impact littoral transport. It would be out of the littoral system completely. But that's a good idea. If we have a major storm, that's another question. If we get hit by a Category 5 or 4 storm, we're going to lose a lot of infrastructure, and soon some new inlets will be opened up. And I think the Corps of Engineers' policy is to close them as quickly as possible. But if they open up in a location, maybe there'll be some push or some thought about keeping one of the inlets open. I don't know.
Well, that's what I'm thinking. If we place less sand at specific points over time, it might allow for washover. We can identify those points.
Yes, right now that's not in the plan. The plan is to hold the coast at all cost. Hold the coast at all cost.
Fort Lauderdale, it looks like they've got a pump that on the north side that pumps sand to the south side of the inlet.
Yes, that's called the fixed sand bypassing plant. They've got one at Palm Beach Inlet, I guess probably Port Everglades. There's one, I think, at Boynton Inlet. We have several of those in Florida. One of the few places in the U.S. where they have these permanent sand bypassing plants. And that's another thing that you can do. If you look at the historical record of the opening up and fixing and stabilizing tidal inlets in the late 1940s and early 50s in the Northeast, there was always a plan to bypass sand. But in the end, it was dropped because it was just too expensive. And so the Corps of Engineers knew well what was going to happen, but there was no political will or financial will to actually add that to the system. Now we have our local inlet here to the north, Sebastian Inlet, which has a very good sand bypassing plan, and they maintain the littoral transport through a lot of sand bypassing, some of which they do in cooperation with, and beach fills in cooperation with Indian River County. So it takes a big effort to manage these systems. Any other, this, sir?
How are we going to get permitting with any kind of inlet pipe to even proceed with this?
So the question is, how would you get permitting to do this?
Especially in River County, we have a hard bottom here that it's sacred. We can't do anything to it. It takes us 5 years to get a permit to do a beach project.
Yes, and we understand that. And I think the answer is that could be part of the phase 2, if there is a phase 2 of this study, a permitting process, a permitting analysis. How can you get something permitted? You would obviously have to go underneath the superficial exposures of the rock reef. Again, directional drilling would be one of the ways to do it. But I admit that the permitting will be fairly substantial effort. And in the end, we don't know really whether it'll be permittable or not. I don't think Florida Tech will be directly involved in, well, we'll help with that phase of it, but it'll be probably a commercial effort to develop the permits if in fact we move forward. It's moved forward. Sir.
To everybody, I mean, I haven't been here very long, but I've always heard rumors that there was some type of bypass at the Bethel Creek. Does anybody recall that in the past?
So the question is, has there been historical bypassing or exchange at Bethel Creek? I don't know the answer, but local people might have an answer to that. Anyone know about that?
Records show that there was, but now we're looking at 70, 80 years of a legacy load in the lagoon. So the most important question I think we should ask is whether or not this water would be exchanged into the ocean or just one way.
Yes. Right now, the thought is it's going to be one way from ocean side to estuary side and not the opposite direction.
And that could not be changed once that's all in place, because that shoreline would look a lot different if it ever were to reverse back. And also there are divers, a lot of them. How would that affect the diving community up there?
Well, as at the scenarios that we are considering would not affect diving, so.
Not a pipe that comes in.
Well, there'll be an offshore outflow or intake. That will have to be maintained. There's a lot of biofouling. It'll have to be caged. Yes. Yeah. And so we have an analogy for that, looking at the cooling canals and the intake offshore of St. Lucie as well. So that, it's a continuous effort to keep those clear.
Temperature too, I'm sure.
Yes. Yep. Yeah, so in the model, that's one of the things we're looking at. We actually have nested our model in a larger model, a basin scale model that has temperature and salinity layer by layer, and so those are the boundary conditions, and they're pretty accurate. And so the model that I'm using is nested in that to help us drive it from the ocean side. So we'll be looking at ocean temperatures, the temperature of ocean water coming in, the salinity, and what will be the potential changes in the local salinity and temperature regime as a result of that. All right.
Not cutting you off, but there's a few people that haven't had a chance to ask one question, so we'll do a couple more, and then if we've gotten through everybody that's gotten their initial question answered.
I know it's very early stages, first phase, but it seems like this is an either or, either the Banana River or Bethel Creek. If it advances forward to the second stage, and it seems like it's something that's viable, it is going to be an either or, one location versus the other, and not both. And are there studies
Yes, I know what you mean. When you look at I've done a lot of these types of studies, and when you look at these exchanges, the benefits, the impacts are confined to the compartment. So what we do in Banana River would not have a measurable signature down here in Indian River County. There's just too much water mass in between. So the effects in terms of flushing, salinity, temperature are going to be confined to that particular compartment. We expect to see that in the simulation at Bethel Creek, Banana River, so those are not directly tied together in a strong signature.
But if it's gonna help both, if it's gonna help that area versus this area, who is the person that's making the decision who gets?
Well, it's certainly not Florida Tech. No, it is, you have your state representatives. This is all being worked through a combination of your state representatives in Indian River County and Brevard County. So those people are the group you should be talking to about that. There's no decision, there's nothing on the table. This is just an experiment to see what is feasible. And if it looks good, it looks like there'll be some benefits, then there'll be some work on a part of your state legislatures to work out how we will proceed in the next phase. But Florida Tech is just the scientific and engineering group in this. We're just doing the experiments. Any other people? We have a gentleman here.
I wanted to ask one last question, because she made a good point. What area would this encompass? Because I didn't even know what area that was that you were showing there. How big of an area was that?
So that we will quantify. The question is, what will be the area of influence? What will be the area of influence? So we will quantify that in terms of circulation, temperature, and salinity will be the markers, and the tracer, of course.
This is a huge undertaking, right?
Yes.
So if it's only a matter of, affecting maybe the city marina area and the people who live onto that, I don't know. I don't know the cost versus benefit.
Yeah, it's always the benefit cost ratio, whether you can actually move forward, and that's something that'll be worked out. But for us at Florida Tech, we are looking at the sphere of influence. So in our final report, we will get back to you and report on that. What we think let's say the signature of the pumping station is in Indian River County. Sir.
If this was ever implemented, are we talking about something that would be completed in 5 years, 10 years, 15 years?
Multiple years. I think there might be a permitting process that'll take a year or two. I think the financial and political process might be longer. I don't know. Again, we're not directly involved in that. We'll do the engineering design, the study, the baseline surveys, the numerical modeling. Then it's up to really you. How do you want to proceed? Is it worthwhile to undertake all of the effort to make this happen in the back of the room?
Just a quick question. It seems like all the modeling you always have done is water coming in. Have you ever modeled the water coming in and then different times water going out, simulating high tide in the ocean with low tide necessarily your lower tides in the lagoon, and then vice versa, since Bethel Creek is directly across from the main relief canal, there may be times where you would let water back out.
No, we have not done, the question is, have we looked at a two-way process coming in and then going out? Have not done that. I will probably run at least one model experiment on that. But again, there were some thoughts about not pumping lagoon water into the coastal ocean, so it's probably nothing that will move forward. But I'd like to do that experiment just to understand how that works. There's also a misconception that pumping water 10 cubic meters per second, or even the weir amount of water volume coming over the weir, will have some impact on flooding. And if you look at the volume of water that we can pump or allow in over the weir, just not enough volume to have a significant impact on water elevations. Just cannot engineer that. Opening up a tidal inlet is a different story because you have a large tidal prism flushing in and out. But what we can engineer in this a little bit of geoengineering will not, in my opinion, we'll look at this, of course, in the model runs, have an impact on local water levels. Any other questions? Okay.
I've got a couple closing items, but thank you.
Okay.
Well, 10 years ago, the enthusiasm for Bethel Creek has really still been the biggest topic of conversation that I have with people out in the community. And it was always, how do we get a phase one? How do we get a phase one? And finally that money got put in the budget, and that's gotten us to phase one. The money was sent to FIT, and then we kind of, in River County, kind of worked and lobbied to make sure Bethel Creek was taken a look at in that consideration. The phase two money, my understanding, is in discussion in the state budget. The House and the Senate have about a $600,000 difference between what one side wants to fund versus the other side. I think we have most everybody's email in the room. If we don't, when you leave, if you wouldn't mind giving us that. When I see information that we can send letters or reach out and send emails to particular elected officials to help them support fully funding both sides of this in the House and the Senate, I'll get that information out to you so you can participate and help drive the conversation to make sure that gets fully funded, as well as our septic to sewer gets fully funded and other undertakings that the county does on an annual basis. You know, the Bethel Creek flushing connection isn't a silver bullet. It's one step of many. The city's been doing their STEP program, which has been pretty successful. The county septic to sewer has been successful. They're just incredibly expensive to undertake. We have, I don't know the current dollars of what we've been awarded for this year going forward, but we will keep chipping away at those high priority areas to convert those. And then there's a part two of that. If we said we wanted, let's say magically we had $100 million to do septic to sewer conversion. For every house you convert from septic to sewer, you now have reuse water that you have to place somewhere. So you have to have the reuse discussion with the septic to sewer, because without the reuse placement of where that water can go, you can't process the sewer. So for every 1 million gallons of reuse water that you don't have a home for, that's about 9,500 septic to sewer conversions you can't do. So we have to look at both sides of this to make everything work. So if you haven't signed in, so if you did sign in online, we have your email. We can send that information out to you. I did have one question for Dr. Zerillo. Is the completion of the phase one is June of this year? June 30th. Okay. Right. And then hopefully the phase two money will become not vetoed by June 30th, and then the winner can go forward. But we'll continue to keep raising the flag and cheering for the Bethel Creek location. I think it has a lot of things going for it, and I think it would be a great place to try the initial connection. With that, if you don't, does anybody else have any other questions from the room? Yes, Mark.
Tim, have you all looked into getting the permits?
For this?
Yeah, before we do a lot of study and everything, it seemed like we ought to talk to whoever it is that issues permits.
Not specifically. I think that conversation will come in the phase two, which would be the more design and permitting hurdles. I did take the opportunity going back a few years ago when I had the person that actually runs the day-to-day operation of the Destin Harbor. They said, before you have them come and speak, you might want to talk to Army Corps, make sure they're still happy. You might want to talk with the Water Management District in that area and all the players who help fund it. I said, that's a great idea. So I reached out to each of the agencies, and some of the folks that originally permitted it were still there, and they were much more than pleased with the outcome of it. But yes, permitting will be, I don't want to say an insurmountable task, but you have to have the data to show why did you pick and why do you want to do it here as part of your permitting. So, you know, that would be, right.
How long is this gonna take? I have my lifetime?
Well, June 30th is the deadline for the phase one, and in that, it'll either be Bethel Creek or Northern, or who knows, maybe it can be both. Pardon me?
So on June 30th, the site will be selected.
Correct. Yes, that's my understanding, is that which location would be. Now, initially, I believe the original 800,000 was to study one site, and it ended up being studying two. I don't know if we can keep splitting the apple 2 times and get 2 phase 2s out of the same money. I don't know, that's a FIT if they can do it for the same amount. No, okay, well then I stand corrected on that. Okay. Okay, great. Yes, in the front here.
Someone, this is a big study here, of course. And Dwayne DeFreeze actually mentioned something about, it would just stop the input of the stuff, right? So ironically, this site has been the cause of a major sewer leak right there, tens and hundreds of thousands
Right.
of gallons of raw sewage. Has there been any plans of studying our sewer infrastructure?
That is a city question. It's a city sewer system. I would say that my interest in the benefits of seeing Bethel Creek get improved was not related to the sewer leak. Obviously, that took it longer to dissipate and to move out of the area because of the limited flow in there. But I know that the city made repairs on that line, and the city has other ongoing sewer expansion improvements, enhancements. And before Monty goes out the back, the city manager is in the back of the room. You might catch him or reach out to him to see what the city's plans are. But that was more of a coincidental event, unfortunate event. But and even if we put everybody on septic to sewer tomorrow, I still think the legacy issues of Bethel Creek, Flushing would still benefit it, even if you did convert everybody over to septic to sewer, not just on the beach, but just county-wide. That's just, in my mind, in my non-scientific hydrological thinking, it's the middle between 2 inlets, so it has the least opportunity. It dead ends into an area that has no way for the water to escape or circulate, that it's ripe for something. Hopefully it's a Flushing connection. And I know Barb Schlitt and I grew up, I know we all played in the Bethel Creek area, and that was where our field trips were from St. Helens. When we were in grade school, we'd go minnow collecting and those things. And so we've all spent a lot of time growing up on those areas there. And we'd like to see it preserved and have the opportunity to recover and be like it used to be. Any other questions? Hearing none, thank you everyone for attending today.